All right, so I'm going to go ahead and do the distance notes. So I'm going to kind of make that a little bigger there so we can see. So when we're talking about distance on a line, okay, you think about how to graph a line, then if I were to put a line like this and ask you how far apart it is from here to here, you would just say, well, Miss Rose, I can count that. That's 1, 2, 3, 4 units. And you could. And then let's say I had a dot from here to here, and I said, how far is that? You would just count it and say, well, that's 1, 2, 3, 4, 5, 6, because the X and the Y axis are number lines. And so we can count along that number line to tell how large or small a number is. Now, so the problem comes in when I don't have it on a straight line. So when it's slanted. And so one thing that I want you to understand is that we can never, ever, ever count a slanted line. Okay? And something's happened again to my sound. Let me see. This says headphones. That's playback. That doesn't work. Okay, so let me see here. All right, now let's see if you can hear me. All right, so what I'm going to do is when it's ever slanted, we can't count that because we don't really know what's in between the boxes because it cuts the boxes in half. So what I'm going to do is I'm going to draw back from my memory about the Pythagorean theorem because the distance formula, and I want you to write this down so that you know what it is. The distance formula says I'm going to take the square root of my x2 minus x1, and I'm going to square it, plus my y2 minus y1, and I'm going to square it. Now, that's the distance formula. Now, if we look at this, when you say x2 minus x1, you're just counting how far it is on the x-axis. When you say y2 minus y1, you're just counting how far it is on the y-axis. So if you think about this, if I'm trying to go from dot to dot and I want to know how far it is on the x-axis and how far it is on the y-axis, I'm making a right triangle. And so we learned about the right triangles in Algebra 1 and then in 8th grade math. And so if we remember that, Pythagorean theorem says a squared plus b squared equals c squared. And when I'm looking for c, that I would have to take the square root. So this is really just the Pythagorean theorem. And when it's on a grid like this, we can just count, okay? So if I count this, say, Miss Rose, my difference in my x's is 1, 2, 3. My difference in my y's is 1, okay? And so then if I take those numbers, it says to square them. So I can say 1 squared plus 3 squared, or 3 squared plus 1 squared. We can add in any order. And so when I do that, then I am going to take my calculator. And so this might be something that you've not done before, but I'm going to hit, if you notice right here, x squared and the square root are the same button. One's blue. That means they're inverses of each other. So anything that's blue on your calculator, you want to hit the second button first. So second square root, and then I'm going to type in 1 squared plus 3 squared. And so that's going to give me my answer. Now remember, we want to round to the nearest tenth. So I'm going to make this little mark, which means approximately, because I'm rounding it, 3 point. And so when I'm rounding to the nearest tenth, the 6 makes the 1 go up to a 2, so 3.2. Okay? Now, if you wanted to actually put your points in, the point here is -5, -3. And we're pulling all the way back from middle school here. So -2, -2, just pulling points off a grid. And so then if I look at this, the distance from, if I were to type in my calculator, -5 minus -2 squared plus, and then my y's would be -3 minus -2 squared. And if you look at this, I may have done that wrong. That's -2, -2. That's -5, 1, 2, 3, -5, -3. -3 minus -2. Okay, yeah, I'm good. So when I do this, I get -5 minus -2 is actually -3 squared. And then -3 plus 2 is -1 squared. And so you say, well, that looks different than this. Well, what happens is when we square a negative, it becomes positive. So this is really just 9 plus 1, which is 10. This is 9 plus 1, which is also 10. So you can see how writing all of this may be a little more difficult than this, especially when it's on a grid. So again, here's what I advise to do when it's on a grid is if I'm asked the distance, I'm going to go straight down and straight over, okay? And what I mean by that is let's say you had a line like this. I can't just draw a triangle all willy-nilly like this. That doesn't work because I can't count any of those because they're all slanted. But I have to, if I make straight lines, I can count those. So this won't work. We got to go straight down and straight over. So 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3. And then once I count it, then I say the square root of 7 squared plus 3 squared. And then I go from there and go right into my calculator, the square root of 7 squared plus 3 squared. And so if I round this correctly, it's going to be approximately 7.6 because the 1 makes the 6 stay. So 4 or below stay, 5 or higher go up 1. We never go down, okay? All right, so then here I'm going to draw this one and then this one. And so that's straight out, straight over, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Now, I had the question, Miss Rose, what if I drew my triangle this way, like straight up and straight over? Well, did you make a right triangle? Yes. Can I count it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I'm still going to get the same two numbers either way I draw my triangle, as long as I go straight up and straight over, or straight down and straight over. So 6 squared plus 4 squared. Okay. And so then here, I'm going to say the square root of 6 squared plus 4 squared. And so that's going to be approximately 7.2. All right. So one more over here. I'm going to go straight down and straight over. So that's going to be 1, 2, 3. So 1, 2, 3. And then over 1, 2. So that's 2. And so then the square root of 3 squared plus 2 squared. And so then the square root of 3 squared plus 2 squared. And so that's going to be approximately 3.6. Okay. And then the last one of this type, and most people have been in class, they really are getting this and doing well with it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. And then 1. Now, I do have some people that'll say 1. Don't count 1 till you move your pencil. 1, 2, 3, 4. So 4 blocks. So this is 4. And so the square root of 9 squared plus 4 squared. And again, I'm going to type that in, the square root of 9 squared plus 4 squared. And so that's going to be approximately 9.8. Okay. Now, the game changes when we get to ones like number 6. Could you put these on a graph and then draw your triangle? You could, but if you don't have graph paper, that's going to take you a little bit. However, remember up here when we talked about the formula, it says to subtract your x's, subtract your y's, and square those values. So I'm going to use that here because I'm going to see how far it is from x to x. So I'm going to say 8 minus 6 and get that number, which will be 2. And I'm going to say -1 minus 0. The formula up here is always minus. So this minus is always there, okay? And then I'm going to square those two numbers. I'm going to put a plus sign and I'm going to square those two numbers. Those become my two numbers. And see, now you can see it looks like, ooh, sorry. I'm going to square those two numbers. And now you can see it looks like this one over here. You say, well, Miss Rose, this is negative. But what happens when I square a negative? It becomes positive. So I don't really worry about this. I can just do the square root of 2 squared plus 1 squared. Because when I square that negative, it's going to become a positive. So the square root of 9 squared plus 1 squared. And so that's going to be approximately 9.1. Okay. Now, the other thing we know when we talked about Pythagorean theorem is that when you had the C side, it is your largest side, always. It's your hypotenuse, which is your largest side. And so if I look at all these numbers, that my answers that I get, they should be bigger than my other two values. So 7.6 is bigger, 7.2 is bigger, 3.6 is bigger. And so you say, well, Miss Rose, I don't know. Well, we got this was 2 and this is 1. That should not have been 9.1. I've done something wrong. See, good way to check myself. The square root of 2 squared. Oh, go back. Mercy. Squared plus 1 squared. So see, that was a great way to check myself. Something was wrong there. And so then that should have been approximately 2.2. My bad. But it's still bigger than the other two. All right. So then we're going to just keep practicing this. So I'm going to say, how far is it from -5 to -6? So I'm going to say -5 minus -6. And I'm going to square whatever that number is. Plus, I'm going to say 1 minus 6, and I'm going to square whatever that number is. Again, I'm not worried about if it's negative. If you put it in there and square it with parentheses, you'll still get the right answer. But if you don't put parentheses in, you won't. So -5 minus -6. I'm typing in just what I see. And so that's going to be 1 squared plus 1 minus 6. And that's going to be -5. Again, not worried about the negative here. Square it. Oh, square it. I put the wrong place there. And then, and put my square root in. So the square root of 1 squared plus 5 squared. Now, what I was saying a second ago, and I'm going to do this on the next one. So we got approximately 5.1 because the 9 makes the 0 go up to a 1. Okay. All right. So look in here. I'm going to do this again. 1 minus 3. So 1 minus 3 squared plus -7 minus -1 squared. So watch what happens. If I do this, 1 minus 3, that's -2. And I square it plus, and then -7 minus -1 is -6, and square it. Now, if you do this and don't take off the negatives right here, your calculator, and without the parentheses, your calculator will make you miss it. Watch what happens. -2 squared, I'm going to put it in without parentheses to show you, plus -6 squared. And it says, oh, I can't do that because you've got negatives under a radical, and you talk about that in Algebra 2. So I'm going to do it correctly and say the square root of -2 squared with parentheses plus -6 squared. And it's going to give me an answer of 3.2 or 6.3. Sorry, I'm going crazy. All right, now here's what I was saying. Because when we square it, it's going to become positive. If I just say the square root of 2 squared plus 6 squared, watch what happens. I get the same answer. So that's why I'm saying if it's negative, when you square it, it's going to become positive. So you don't have to type the negatives in your calculator or use them. It's kind of like a way to not make an error. So 2 to -3 is 2 minus -3, and we square that, plus 5 minus 6, and we square that. So what happens is when I type this in my calculator, I'm going to get 5, and I'm going to say 5 squared. And 5 minus 6 is -1. I'm just going to put 1 because we just showed you why you can just leave that off. So then the square root of 5 squared plus 1 squared. Now, here's the other nice part about this. Again, that was 5.1. So you don't have to go this one to this one. You can go this one to this one. So I can say 6 minus -3 and square it, plus -2 minus 5 and square it. Because it doesn't matter whether numbers are negative or positive. They both can be set up correctly. So this, when I type it in, I'm going to get 9 squared plus, when I type this in, I'm going to get -7. So it's okay if I just put 7 and then square it and take the square root. On distance formula, distance only, because when you square something, again, it's going to become positive, and that's why. All right, 7 squared, and then I get 11.4. So approximately 11.4. And these two situations are all you're going to need for your distance practice. Okay? All right.